they just find the recording. I'll still be around waiting for them. So I want to welcome you for this class on matrices. We are saying just a matrices is an m by n, where m is the number of rows and n is the number of what? Columns. So we call an m times n matrix, which is a rectangular array of numbers, basically arranged. You can be able to see the rows. The ones that are standing up are basically the what? The columns. Types of matrices, we have row matrix, a matrix having only one row. So we say the rows go horizontally, and then a column matrix has at least vertical now, has just only m rows and one column. So you can be able to see that. We have a square matrix. A square matrix is whereby the number of rows and the number of columns are the same. That is a square matrix. We have a diagonal matrix. This one is a square matrix having the main diagonal. So you can be able to see the main diagonal is the one that cuts basically from where? From left to right, basically at the center. So if you have at least zero non-zero elements there, it's called a diagonal matrix. Then we have a scalar matrix. It is a diagonal matrix having each diagonal element equal. It's called a scalar matrix. So if you go to the diagonal matrix and you have basically the leading diagonal here, all of it to be identical, then we call it a what? A scalar matrix. When you go to unit matrix, so the unit matrix is a diagonal matrix having the leading diagonal element to be number one, only number one. Yes. And there I've said basically for a unit matrix, if you multiply by its inverse, you multiply any matrix by its inverse, you'll be able to get the identity matrix. Then we have a null or zero matrix. Basically, all the entries are zero. Can either be a column, can either be a row, can either be a square matrix. Is any matrix whereby all the entries are zero. We have upper triangular, just like the word the upper triangular. So from the leading diagonal, you can be able to see the elements on the lower side are zeros. You can be able to see the elements on the lower side are zero. So it's called upper triangular matrix. So it has to be a square matrix first of all. And then you have lower triangular matrix. The upper side now is the one that has zeros because we want the lower to have non-zero elements. We have the transpose of a matrix. So when you interchange the number of, if you interchange the rows and the columns, then it becomes a transpose. So you can be able to see the first element. We have what? Maybe I can be able to do here on my board to be able just to demonstrate the transpose of a matrix. The transpose of a matrix. Let me share this one. Let me share the other board. Demonstrate the transpose of a matrix. Transpose of a matrix. So the transpose basically of a matrix, if A my pen is refusing. If A is equals to, let's say, 2, 4, 6, and 9, so the transpose denoted by that, 80 will be given by, so this one, you can be able to see this one is the what? These are the what? These are the rows. Those are the rows. So if I interchange this one, this is my row 2, 4, it will come here. It will become my column. And then 6, 9 again will become my column, like that. So it becomes a transpose matrix. I can be able to do another one for a 3 by 3 just to demonstrate. 2, 1, 6, 3, -1, 4, then 10, 9, 5. So I'll have these ones. These are the rows. Can be able to see the transpose. Basically, the rows will become 2 and 6 will become my what? My column. Then I'll have 3, negative 1, 4. Then I'll have 10, 9, and 5 to be my what? My transpose. So that one will be the transpose basically of that. Sawa. Yes. So the transpose you just interchange the rows and the columns to be able to get that. So you guys can be able to go through the definitions. Let me go to matrix operations. I do a bit, and then we can we call at least we end the class today early. So today we might end up the class early if you understood what we are doing. So the other one is basically the what? The operations. Operations. Let's start with addition. The good thing about matrices already you have covered, so it's not hard. So when you have, for example, when you have 1, 2, 4, 5, and we are adding 2, let's say 6, 7, 8, and 9. If you want to add this matrix from the notes we have said, you add the what? You add the corresponding element on the particular row and the particular what column. So like this one, the one in yellow, this one 1, and this one 6. This one I'll add that here. The value will be there. And then this other one that is in blue, the 2 and the 7, I will add with that element there. I can be able to see they are on identical positions. And then I add the 4 and the 8 together. And then I'll add the word finally, the 5 and the word and the 9 together. That's how you do it basically. You add the same in the same position. So so I'll have 1 plus 6. Then I'll have 2 plus 7. Then I'll have 4 plus 8. And then I'll have 5 plus 9. When you do this one, you should be getting what? That is 7, 9, 12, and what? 14. So identical, the one that we have done. So this one will go with that one. This one will go with that one. The 2 will go with 7, and then the 1 will go with 6. So that's how you add basically. When you come again to subtraction, it's the same thing. Subtraction. When you have negative 2, 4, 5, negative 9, minus 3, negative 1, 6, negative 2. So again, I'll do the same thing. The ones that are marking basically are in the same positions. The 2 will go with the 3. What you see, the 9. Sorry, I should have used a different color. The 9 will go with the 2. The blue will go with the negative 1. And finally, the 5 will go with the 6. So this is what I'll have now. When I do like that, what I will have, I'll have negative 2. There's a minus 3. Then I'll have 4 minus 1 is always good to put brackets, and then 5 minus 6, and then negative 9 minus 2. If I do this one correctly, this is what I should be able to get. So I'll get negative 5. I will be able to get 5. I'll be able to get negative 1, and I shall be able to get what? Negative 7. That one. So I'll first of all take a question from you. If you have any query, you can be able to say, or you can tell me to proceed, because I'm going now to the last operation. Today class, I want it to be as simple as that. Anyone with a question, but you can tell me to proceed. So I proceed. So I'll go now to multiplication. Maybe multiplication may be a hindrance to some people, but it's not hard. So the final operation is multiplication. So when you have basically for a matrix, let's say A and B, C and D, you multiply with, let's say, what? I want to use A, B, C, D, and then E, F, G, H. You want to multiply those two matrices together. This is what you normally do. We what? We normally go row in the first matrix, and then we go column. So you can be able to see the one that are in yellow. I'll multiply like that. Go to multiply with that. So row, column. But again, the two matrices, if I have this one is a 2 by 2 matrix. Sorry for that. This one is a 2 by 2 matrix. 2 by 2. This one is a 2 by 2. So you can be able to see, for you to be able to multiply two matrices here, remember this one is for column. This one is for column. This one is for column. The column of the first matrix has to be the same with the number of rows in the second matrix. They have to be identical. And then whatever that is remaining here, we should be able to expect that one a 2 by 2 matrix. So the number of columns here and the number of rows should be identical if you want to multiply. So in the first entry like this one, I'll have A times what? A times E, and then plus, my body will not be, let me, I have to do it here down. My body is not big enough. So let me do it again here. A, B, yes. Can you be able to hear someone? It's just a noise. Okay, sound. So A, B, C, D, and then E, F, G, H. You have said we are going like this. You go like that, and then you go to the what? You go like that. A row, column. So you shall have A times E plus B times G. That's the first entry. The second entry, again, we shall have again row column for this one, for the one that have F and H. So again, I'll have A times F plus B times H. Then when you go to the lower one, you'll be able to have again C times E plus D times G. And finally, we shall have C times F, C times F plus D times H. So that's how you do it. You go basically row, column, always. Row, like that, and then the column like that, going down. So that's how you multiply two matrices. And you have said you can only be able to multiply if two matrices have the same number. The first matrix, the number of columns and the number of rows are identical to the second one. There's no other way. So I'll do an example. Start with a simple one, a 2 by 2. Start with a 2 by 2. We'll have 1, 2, and 3, 5. Negative 4, 6, negative 1. Let's try that one. So I'll multiply the one. I'll do row, column. I'll do row, column, like that. So I'll have on the first entry, I'll have 1 times negative 4 plus 2 times negative 1. This is 4. Then here, the second one, I'm able to use a different pen just to demonstrate. In the second one, I'll have 1 times 6 plus 2 times 2. In the second one, this is what I'll have. I'll have 3 times negative 4 plus 5 times negative 1. And finally, I'll have 3 times 6 plus 5 times 2. Now, the arithmetic, when you have a calculator, is easy to do. So this one is what we should be able to expect in the final answer. 1 times 4, that is negative 4. You'll get negative 6. And then this one you'll get 6 plus 4, that is 10. Then you'll get negative 12 minus 5, negative 17. And then 18 plus 10, 28. We are done with that one. We are done with that one. Basically, that is for a 2 by 2 matrix. So 2 by 2, you can easily be able to see 2 by 2. So you can be able to see here, the number here, the number of, I think I demonstrated here, the number of column, that one, and that one, in yellow, they are identical. So whatever that is remaining, basically, in pink, we should be able to expect a what? A 2 by 2 matrix. And that's what we have here. That is a 2 by 2 matrix. I'll do another example, then I'll ask, I'll wait for any queries. Let me do another example. 2, 1, 3, 2, 0, negative 1. So that one. So if I do that one again, this one is number 2 now. Number 2. So again, I'll have to confirm first of all if it is possible to multiply these matrices. So the number of rows for the first matrix, it is what? The number of rows are like this, are the ones that are going down. So the number of rows are 3, the number of columns are 2. In the second matrix, the number of rows are 3 and the number of columns are 3. So I confirm whatever that I'm putting in yellow here, are they identical? The 2 there and the 3 in yellow, are they identical? I'll start from there. Are they identical? Is 2 equal to 3? Is 2 equal to 3?
No.
No. So it is not possible to multiply. So here, not possible to multiply. Not possible to multiply. Not possible to multiply. To multiply. Since number of what? Column. In the first matrix. In the first matrix is not equal to number of rows in what? Second matrix. So that is the reason why. Not possible because the number, they are not equal. So you must really be careful. You must be really be careful when you're multiplying. So I'll go now the final example. Number 3. 4, negative 1, 2, 0, 3, 1. 2, 3, negative 4, 9, -1, -2. Let's confirm that one. Let's confirm that one if it is possible to multiply first of all. It's possible to multiply that one. So here, this one is a what? We had said this one is a 3 by 2. Here, the number of rows are only 2, and the number of columns are 3. So you can be able to see it's possible to multiply that one. It is possible to multiply because the number of columns in the first matrix is the same as the number of rows in the second one. And basically, we should be able to expect a what? A 3 by 3. Our final answer, we should be able to have a 3 by 3 matrix. So you can easily confirm. So let's do this one now. So, so you said row column. Remember, row column, always row column, row, and then the one in red. Row column. That. So I'll multiply those ones. So this is what I should be having now. In the first one, I should have 4 times what? 4 times 2 plus -1 times -1 times 9. Then in the second one, I should have 4 times 3 plus -1 times -1. Then in the final column there, I should have 4 times -4 plus -1 times -2. I go now to the 2 and 0. So 2 times 2 plus 0 times 9. That's the first one. Then I should have 2 times 3 plus 0 times -1. 2 times -4 plus 0 times -2. The second one. Finally, I'll have 3 times 2. 3 times 2 plus 1 times 9. And I'll have 3 times 3 plus 1 times -1. Then I'll have 3 times -4 plus 1 times -2. The negative there. So this one is just a matter of just putting everything in a calc. So when I put that one in a calc, this one is what I should be getting. The first one there, 4 times 2, that is 8. 8 minus 9, so I should get -1. That is 12. 12 plus 1. That is, sorry, there's a 2 there. So that is -16 plus 2. -14. Then the other one is 2 times 2 plus that one, you can just get it as 4. Sorry. And then you should be able to get it at 6. Then, is that one a 2 or a 4? Let me confirm. Or 2 times -4. 2 times -4, you get -8. And then that is 6, 15. And then 9 minus 1, 8. -12 minus 2. -16. Sorry. -14. -14 here. That's -14. And we are done. And you can be able to see it is a 3 by 3 matrix. It is a 3 by 3 matrix. So the arithmetic has no problem as long as you know how we are multiplying. Because knowing how to multiply the other one, a calc will be able to do that one for you. So remember, it is row, column, row, column, row, column. Very important. So I'll take you back. Anyone with a question? Let me refresh the board. Okay, let me refresh the board. Now I've refreshed the board.
Yeah, you're more.
I've refreshed the board. So again, I'll go back to the example. So you can be able to see what we are doing. We are doing the row, then the column. So we are multiplying the 4 times 2, negative 1 times 9, like that. And then you are saying the most important thing is to first of all confirm whatever that I have in yellow, this one here, and this one, are they identical? They are identical. So the three and the three on the outerwards, we should be able to expect that matrix. So I multiplied the 4 times 2, negative 1 times 9. So again I went again with the 4 and negative 1. I multiplied basically with this one. So that's how you do it basically. That's how you do it. So I went with like the whole of these ones. I multiplied with that one, again with that one, again with the whole of that one, again with the whole of that one. So that is the first one, and then the second one, and the third one, and then you continue like that. So that's why you have a 3 by 3, and then you just do the using a calculator to solve that one. You should be able to get those values. So I was asking anyone with a question so far? Anyone with a question so far? Anyone with a question? Anyone with a question so far? We start from there, or I do a final like the same. So I've interchanged. The first one we got a 3 by 3 matrix. This one we are getting a 2 by 2 matrix. Are they the same?
No.
Even they are not the same. So when you interchange the matrices, basically it is not commutative. And on the notes, I think I've said that it is not commutative. When you interchange the matrices, you should not get the same thing. So they are not the same. So, but I can still be able to do this example, then I do a final example. So let me do this one. So how do you multiply those ones? So I'll go to the row and then the column there. So we expect a 2 by 2 matrix, our final answer. So this is what I'll have, a 2 by 2 matrix. So the first one I'll have 2 times 4, 3 times 2, and then negative 4 times 3. That's what I'm doing. So I'll have 2 times 4. I'll have 2 times 4 plus, if you go here, 2 times 4, and then 3 times 2. 3 times 2 plus what? Negative 4 times 3. Negative 4 times 3. It is big. That is, let me rub this one here. That should be small. So this one is not needed. So that is the first entry. If I go to this other entry now, I'll have now for the second column 2 times negative 1, 3 times 0, negative 4 times 1. So 2 times negative 1, 2 times negative 1 plus, and then I'll multiply the 3 with 0, 3 times 0, and then finally I'll add negative 4 times 1. Negative 4 times 1. Then I'll go basically with the other one. I'll go with the other one. The other one is what? 9 times 4. 9 times 4. 9 times 4. And if you go up, I'll have negative 1 times 2. And finally, I'll have negative 2 times 3.
Kefunga yale. Yayo liambwe kan.
Benjamin, kindly mute. Kindly mute. So, and then I'll have now 9 times negative 1. 9 times negative 1 plus. Again, remember I'm going row, column. And then 9 times 0. Sorry, negative 1 times 0. And finally, I'll have negative 2 times 1. I have. If I do this one, for me, I have a calc, study I have a calc. Let me do this one quickly. 8 plus 12. Sorry, 8 plus 6 minus 12. That is 2 for the first entry. The other one is negative 2 minus 4, negative 6. So the other one is 13 minus 2 minus 6. 5. And then have negative 9 minus 2. That is 11. And I'm done with that one. So you can be able to see for two matrices, we are getting totally two different answers. But then you have A times B. A times B can never be equal to what? B times C. So it is not commutative. It's not commutative. It is not commutative. It is not commutative at all. It is not commutative at all. So I had promised that one was again a good example. So let us first of all do the final one at 3 by 3, and then you can be able to call it a day. We don't have any other questions. So this is what I have at 3 by 3. It is example number 3 now. So I'll have 1, negative 1, 0, 2, 3, 1, 0, negative 2, 4. Then you multiply this one with negative 5, 0, 1, 2, negative 4, 3, 3, can have another 3, negative 3, another negative 1, and then another 0. So that one there. So we can start. Is it possible to multiply those two matrices? Let's start from there. Is it possible to multiply those matrices?
Yes, it is possible.
Yes.
Yes, it is possible because we have a 3 by 3 matrix and a 3 by 3 matrix. By the way, if two matrices are identical, it is easier for us. It is straightforward. This one is a 3 by 3. This one is a 3 by 3. You can be able to see whatever I've circled there, they are identical. They are the same. So you should be able to expect a 3 by 3 matrix in the final answer. A 3 by 3 matrix. So I'll start multiplying this one. So I'll be referring, my board is not that big, so I'll just be referring back. So we need a 3 by 3 matrix. So I'll have the first entry. So we said row column, remember? Row column, row column, row column, like that. So I'll have 1 times negative 5, 1 times negative 5, 1 times negative 5, plus negative 1 times 2 plus 0 times negative 3. That's the first entry. The second entry, this is what I'll have. I'll have 1 times 0, 1 times 0 plus 1 times 0 plus negative 1 times negative 4, and then 0 times plus 0 times negative 1. Is it a must to do what I'm doing? This one is just for demonstration. You can be able to see the way it is taking a lot of my board. It is not a must to do all this. If you have a calc, you could just have taken the digits the way they are, and then you could have just multiplied and gotten the final result. Because now I'm wondering, now my board is not that big, so I have to repeat again. The board is not that big. It's not a must to do what I'm doing all this. My board is so, but it's just good to demonstrate. My board is not that big. It's not that big. So pens. So if I had a calc, it's just inputting the values as you multiply. Just input the values as you, if I had a calc. So I'm assuming at least this one is just for demonstration. So we had 1 times negative 5 plus negative 1 times 2 and then plus 0 times negative 3. Then let me just use another pen for the sake of, so the other one was 1 times 0, 1 times 0 plus negative 1 times negative 4 plus 0 times negative 1. Then I go now finally to the, I'm able to go to the other pen. I'll have 0 times 1 plus 1 times 3 plus 4 times 0. So I'm able to see my board is not that big. So I'm overstretched, but it's still okay. So I'll go to this other one. Basically now I'm on the second row of 2, 3, and 1, and I'll do the same 2, 3, and 1. So 2. So I'll have 2. 2. My 2 is not coming out clearly. Two times negative 5 plus 3 times 2 plus 1 times negative 3. The other one is now 2 times 0. 2 times 0 plus 3 times negative 4 plus 1 times negative 1. Then I'll go basically now the second row with the last column. So 2 times 1, 2 times 1 plus 3 times 3 plus 1 times 0. And then I go with the last column with the first row. So I'll have 0 times negative 5. The other one is negative 5 plus negative 2 times 2, and then plus 4 times negative 3. 4 times negative 3. Then I'll have again 0 times 0. 0 times 0 plus negative 2 times negative 4 plus 4 times negative 1. And now I go to the last one. The last one is 0 times 1. 0 times 1 plus negative 2 times 3 plus 4 times 0. So again, I've said it's not a must to do what I'm doing. If I had a calc, I would just have taken the values and I would have multiplied, because you can be able to see it is very, very tedious. Very, very tedious to do that when you have a small board. So our final answer, we do our final answer now. So this one is just input everything in a calc and you'll be able to get something. So the first one I'm getting is what? Negative 5 minus 2.
Sir, your
Yes.
first row, third column is not correct.
First row, that column. First row, that column. So 0 times negative 5, negative 2 times 2, 4 times negative 3, 0 times 0, negative 2 times negative 4, and then 4 times negative 1. First row, that column. It's not correct.
Yes, the one for, okay, the first row for this first matrix and then the third column for the second matrix.
Which color?
Yes?
Which color? I have black, red.
Red.
Which color?
The red.
The red one. The one that's starting with 2 times -5.
The one that starts with 0 times 1.
Okay, 0 times 1. Let me confirm. So I have
Wewe mwalimu ameenda wapi?
Hadi board imesimama.
I thought ni
Hadi
mimi
hiyo
nimeachwa
board.
ama ni stima imeenda kwake.
Mwalimu ameenda aje?
Yuko on, sio amepotea aje.
Ni stima.
Ni connection.
Laptop imecrash.
Hmm?
You are making noise bwana during class time.
Bana penja nini mbaya? Benja unatoa Ramoni bana na mwalimu wako class.
Sasa unajua sikuelewa kitu nitaka kuuliza.
Ama ulisahau kaacha na mic on.
Bana nilisahau nikaacha ikiwa on, sasa kai nashangaa naambiwa wewe nyamaza.
Wewe, basi.
Hello. Yes, sema. Ferdinand.
Oscar. Mwalimu amerudi.
Amerudi
ya maziwa.
Ile meeting itaanza saa ngapi? Ile orientation.
Wewe bado unangoja orientation?
Kevo,
Niambie Peter.
umejua bado kuna Bayern mbele. Uje Bayern Munich bana, tunangoja.
We are in class bwana, mwalimu amerudi, naona bodi inafanya.
Nyinyi ndio kungoja. Roba.
Mambo.
Aliaje?
Poa sana.
Nasikia mnangoja game ya Bayern sana, nyingine mna gani nyinyi?
Na kuambia tunaomba sana hata hii mambo ishe, ili mrudi mchapo hii muwekelee bana, mambo yenu ishe hivyo sasa.
Sawa, sawa.
Unajua tu umeshikiliwa tu na hii nini.
Wewe cheka sawa, wewe jisahau tu hapo tu.
Napiga hesabu naona saizi hata sijui hata mngekuwa na kombe gani juu saizi ligi ingekuwa imeisha na mngekuwa na kombe moja bana.
Unajua hakuna hata nyinyi mngebeba nyinyi.
Sisi tungebeba FA na Europa bana. Kwani ukumbuki tulikuwa baya sana Bruno?
Kwanza FA ilikuwa
By the way na miski huunguro sana bana.
game inarudi lini bana?
Nasikia ni fast juu. Unaona saizi tunafutia Bundesliga.
Ngoje,
Roba.
Roba.
Mkenya unasema? Halo.
So alikuwa Nairobi.
Mpaka kieleweke tu.
Lazima.
Roba.
Mkenya. Sema bana.
Hiyo marudiano ya Chelsea lazima tuturudi. Hata tukufe lazima tutagugu tuone results.
Lazima na hakuna ati mambo ya kusema ati Chelsea imesarenda. Lazima watu wanyolewe bana.
Hiyo lazima kieleweke bana.
Lazima hata hakuna tanga nikieleweke. Hata kwe tanga atakielewa.